Thank you for joining the lesson. Good evening. So we're going to discuss mathematics paper 1. That is the Kapsabet mock 2024. Remember to subscribe. Remember to share so that you may invite a friend. You can see people are already in. Today we are saying hi to the class teacher as we wait the opening of schools tomorrow. So recognize your school. Identify yourself with your class teacher and your stream. If your school has several streams, say hi to your class teacher. We are meeting from tomorrow onwards. I hope term 3 shall be great. To all the candidates who are following, want to wish you success. To all the other students, let's continue working hard. It shall be well. Mathematics can be done. We can score better in physics. Thank you. I can see people are already turning up, and this is quite encouraging. So we are starting now. We are waiting. Thank you. People are saying that they are eagerly waiting. We are here to serve you with mathematics. We are here to ensure that you get the best. Click the share button. Click the share button. Invite someone. Just invite a friend. Today will be very quick because there are a lot of concepts to be covered. There's a lot to be discussed, and time is not on our side. We shall even discuss the section 2 of this paper. So we are going to handle at least 100 marks tonight. So please be ready to work with us throughout the broadcast. I hope it shall be well. So in the next 2 hours or so, we will have covered a good ground. Yes. We have the instruction. Then the questions now come. 3.75, and we can see 7.5 are both recurring in the form A, B divided by C. Hence, find the absolute value in B divided by C minus A. So what we'll be doing here is converting a recurring decimal into a fraction. So we begin by letting whatever has been given here to be R, 3.7575, because 7 and 5 recurring. So we go to 10R, whereby it will be 37.5757. Remember, this should continue until on the decimal parts we can get a pair that can be subtracted to give us 0 on the decimal part. So we proceed to 100. Proceed to 100R. 100R equals to 375.7575. That means now the first one and the third can be subtracted to give a 0, such that the decimal part is ending. And so we shall have them subtracted upwards. 375, we subtract 3. This gives us 372. Then on the other side, we will have 100R minus R, giving us 99R. So R will be equal to 372 divided by 99. So when we make it a mixed number according to the instructions, now it shall be 325 out of 33. From this now, it is already in the format A, B over C. Now we want to get B divided by C minus A. So according to the expression, B is 25 out of C, which is 33. Then we subtract the value of A, which is 3. So 25 over 33 minus 3. This will give us a negative now. 2, 8 out of 33. 2, 8 over 33. So that is the absolute value. Remember, sorry, there is this language. It's good for students to be reading the questions carefully. The word absolute value means when we get the difference or whatever computation that we are doing and we get a negative number, absolute value means now just the magnitude of the number, regardless of the sign. We just pick the number, which is 2, 8 over 33. This is the meaning of absolute value. The absolute value. We just ignore the sign and we write the quantity. There is the second question now on factorization. Find the values of P and Q if P squared multiplied by Q squared, Q power 3 that is equivalent to 3087. This means we are going to factorize 3087 with an objective of getting two prime factors, such that when those two prime factors are expressed into powers of 2 and 3, then we can know the value of P and Q. So let's factorize this. 3087. We can see already the number is not even, so we cannot begin with the least prime factor, which is 2. We can't start with 2 in this case. So 3087, we can begin with a 3, yeah. So 3 is giving us 1029. Let's check whether 3 can do it again. Divide by 3, yeah. We're getting a 343. But when we divide by 3 again, it cannot. So we can go to another prime factor like 7. So by 7, I got 49. And by 7 again, whereby I'm getting 7. So this number, 3087, I can see it's equivalent to 3 power 2 multiplied by 7 power 3. And this is to mean, assuming the format here, then it means the factor which has been raised to 3 is our P. So we say 3 is our P. Then the factor which has been raised to power 3 is our Q now, according to that. Therefore, Q is 7. So these are the two values that we were intended in. Let's continue working out now in number 3. Remember to subscribe. Remember to invite a friend. Remember to invite a friend to this live broadcast. Today we're going to learn a lot. Today the lesson is going to be great. Remember to say hi. Remember to say hi to your class teacher. That is your parent. together with the other teachers. That's your parent while at school. Just sent greetings. Machakos to F. Thank you so much. Thank you so much, our boys from Machakos School. Mama Gina girls, thank you. Wow, this is wonderful. This is wonderful. This is wonderful. Mr. Eugene from Mosingo. People are proud of their teachers, let me tell you. And that is wonderful. I might not manage to read all the live messages, but keep them flowing. You are really helping me, Mwalimu, but I cannot pay you because I don't have anything to pay you. God will reward the work of your hands. Thank you so much. My math teacher, Mr. Afuka. Wonderful. That is Katelembo, Center of Excellence. Wonderful. We continue now. Number 3. Remember to subscribe kindly. A Forex Bureau in Nairobi buys and sells selected foreign currencies at the rates given in the table below. We have the currencies there. Then we have the buying rates, and we also have the selling rates of the same currencies. A tourist arrived in Kenya from South Africa with 8,546,000 South African rand. He converted the whole amount to Kenya shillings through an agent at a commission of 2%. While in Kenya, he spent 1/4 of this money, or that is a quarter of this money, and changed the balance to UAE dirham. Calculate the amount of UAE dirham that he received. Calculate the amount that he received. Calculate the amount that he received. We should know that, okay, there are these acronyms which help planners. For example, we say Kefose, then there is a Fokebu. In this case, we multiply. For this particular case, we do division. So for the multiplication case, we are saying from Kenyan, from foreign to Kenyan currency, we use the buying column and we multiply so that we may get the Kenyan currency. So we will take 8,546,000. Then we multiply by the amount in the buying column, for South African rand, that is 7.00. So we just multiplying this amount by 7. When we multiply this amount by 7, let me tell you what we're getting. 8,546,000 multiplied by 7. This becomes 59,822,000 Kenya shillings. Now, this tourist did not get all this amount because of the commission through the agent at the bank. Then it means that because of the paying of 2% commission to the agent, then he only got 98% of this money. He got 98% of the money he had to give a commission. So this gentleman ended up receiving 58,625,560 Kenya shillings. This is the amount in Kenya shillings. The amount in Kenya shillings. Okay, after receiving this amount now, while in Kenya, he spent a quarter of this balance. So instead of me calculating the quarter that is spent so that I may subtract to get the balance, then I'll go direct to get the balance of 3/4 of this amount. So the balance that is being said, the balance for this guy is 3/4 of what he had. 625, 560. So let me compute this. 3/4. So I'm getting 43 million in Kenya shillings still. 43 million 969 170 Kenya shillings. So this is the amount that the gentleman remained with after spending a quarter. And now the next thing is to apply the second acronym, which we are saying KFOSE. From Kenyan currency to foreign currency, we just divide. We use the selling column, and therefore it will be 43 969 170 divided by AE dirham. 7.5. So this is going to give us, this is giving us a 1,172,511.20. That is UAE dirham. So this is the exact amount the tourist received while he was leaving Kenya. Let's look at number 4. Remember to be very cooperative more so when we are handling this. Remember to be very cooperative in this one. Gentlemen from Moka Boys, and this is great. I can also see from HOD, that is Mr. Karani. He promised to invite you people. Iku National, thank you so much. With this work until we do our KCSE, and I will keep it. We shall do until people do their KCSE. Thank you so much, Lugulu girls. Nyaururu High, class teacher, Mr. Gioche. Wonderful. Thank you so much, County High School. Thank you. Thank you. Thank you. This is great. This is great. Let's continue. Number 4. A rectangular garage measures 13.2 meters by 6 meters. The garage is to be covered by square concrete slabs, leaving a margin of 1/5 meters. Calculate the minimum number of square slabs required to cover the garage. Okay, some of these problems, sometimes they require diagram sketching for you to understand what you're being told. For instance, there is a garage here. We are given the external dimensions, but now the slabs are going to be fitted such that they are leaving a certain margin. They are leaving a certain margin. So we are told that it leaves a margin of, when we have a 1/5 of a meter is 0.2. So we will have 0.2 here and 0.2 here, also 0.2 here and 0.2 here, such that if the external length is 6 meters, then the internal one shall be 6 minus 0.2 minus 0.2 again, and that becomes 5.6. 5.6. 5.6. Then on the length side now, we have the external as 13.2 meters, but now the internal one is going to measure when we subtract from 13.2, we subtract again 0.2 and 0.2 on the other side, so it shall be 12.8 meters. So these are the dimensions of the area which is going to be covered by the square concrete slabs. The square concrete slabs. Now that we have the internal dimensions, for us to get the dimension of a square tile which is going to cover this room, the minimum number actually, we need to get the GCD of the internal dimensions. So we need the GCD of, because the area that is going to be covered is going to be 12.8 meters by 6 meters. 5.6 by 5.6. So we're going to get the GCD of both 12.8 and 5.6. It's good for students and everybody who is following to notice something, that getting prime factors for Desmos is not logical. And so it would be better if we convert these units from meters to centimeters or even millimeters, which will take us to whole number dimensions, such that when we multiply by 100, this will become 1280. So we are getting the LCM of 1280 and 560. So we're getting now the LCM. The GCD, sorry for that. The GCD, the highest common factor, HCF, the highest common factor of these numbers. The highest common factor of these numbers. Remember, it is a value smaller than LCM. We are moving from the dimensions of a room to dimensions of a square slab, which means we should get a smaller factor. If we were moving from rectangular tiles to the dimensions of a square room, then we would have gotten the LCM, because we would be looking for a value greater than the provided dimensions. So now that we are moving from the rooms, we are moving from the measurements of our garage into a square tiles dimension. We should get just a factor and not a multiple, and that becomes the GCD. We start with the first. This will give us 640. We proceed, this one be 280. Then by 2 again, I'm getting 320. By 2, 140. Yeah. By 2 again, I'll be getting a... When I divide 640 by 2, 320. By 2, 160. Hey, my brain is tired. This will be 70. Then we can also go again by 2, so that we find ourselves at 80 and 35. 2 cannot divide both sides any longer, and so we can look for the next prime factor which will be able to divide. This is nothing else than 5. So 5 will divide 80 to give us 16, 35 to give us 7. That is the end of the prime factors. Therefore, I'll be using 2 power 4 by 5 as the dimensions of the square room. This is going to give me exactly 80 meters, 80 centimeters. Now, remember, we converted the units. Therefore, we'll be talking about a square concrete slab which is measuring 80 by 80. 80 by 80 centimeters. But now our question is on the minimum number of square slabs required to cover. Therefore, we'll be having the dimensions of the room of 80 by 560. That is the area to be covered. And the area of a square slab is 80 by 80. So when we divide the area of a room and area of one square slab, then we shall be in a position to know the number of square slabs required in such a room. This is giving me 112. So that one is sorted. The other alternatively, on the number of slabs, we can do this. We can have someone saying that along the length, we shall have 1280 divided by 80. So along the length, we're going to have 16 of them. Then along the width, the internal width is having a 560. So divide by the length of a square slab, which is 80. So 560 divide by 80. This is giving us exactly seven slabs. So according to the length, there is going to lie 16 slabs. According to the width, there shall lie 7 slabs along the width, and therefore the total will be the product. I think you know that format of counting a total number of particles in a certain area. So it will be 16 by 7. So 16 by 7 is giving us exactly 112 slabs. This is an alternative. So we can say alternatively. So that is how we get. That's how we get. Thank you so much. Remember to subscribe Miranda High School. Thank you so much. Abigail from Rosoga High. Thank you. Garissa High School. Thank you. Wanga Boys. Thank you. You can see people are from all over. Please continue learning. Remember to subscribe. Sending greetings to our mathematics teacher, Pondo, Raila High School. Wow. Upper Hill School. Thank you. Thank you. Thank you. Thank you. Let's continue learning. The question is saying, use logarithms correct to 4 decimal places to evaluate the third root of 68.37 sine 53.4 degrees divided by 9.4 squared. So let's have this question arranged very well. We shall do it very fast, and I hope that you guys will be following up. I'm going to have a column for all the numbers in the question. Then we can have the standard, which is not a must. Then now the logarithms. We are going to do each computation step by step. Okay, so we will have the numbers here. We shall at this point. Then we shall have the logarithm finally. The logarithm is going to appear on that column. The first number is 68.37, whose standard form shall be 6.837 times 10 power 1. So we will have 1 point as the logarithm. We use the power of 10 in this. So that is 1. Then we now read the log of 6.837. This is going to give us a 4dp 8349. Remember, we've been told to use logarithms. This question is very different from another. Tell you to use logarithm tables. When you are told to use logarithm tables, kindly use the logarithms in the tables. Use the mathematical tables. In this case, we have just been told logarithms, and you can apply the logarithms in your calculator. The next number is the sine of 53.4 degrees. So we look for the logarithm of sine 53.4. This is going to give us, or we can simply get the number in this case, sine 53.4, 0.8028. So we can have 8.028 times 10 power negative 1, which means the log is going to be by 1 point. 8.028. 9046. Now at this point, the first number and the second one have been multiplied, and that means when two numbers have been multiplied, then we add their logarithms. So we shall be adding these two. Encourage students in such a scenario, just add the numbers manually. Please add logarithms manually. Let nothing lie to you, or let nothing tempt you to use the calculator. Please do the simple addition using your free hand and your brain. Masomba Secondary School in Matiliku, Makueni County. This is great. Baringo School, thank you. Thank you, thank you. Let's continue learning. Yeah, Patrick says that you are boosting my grade in mathematics because I was getting B, but I hope I'll get A in my KCSE. All the best, Patrick Monyao. I hope the same. So this shall be 5 when we are adding now. Let me actually use a different color at that point. I'll get 1. This shall be 9, 3, 17. I carry 1. I'll be having 1 plus 1, then plus bar 1, making it 1. So that is the logarithm on the answer part. Let's continue and have the second number, which is 39.4 squared. So we can write, okay, the number is 39.4. This is a 3.94 times 10 power 1. So we shall have 1 point. Now we read the logarithm of 3.94. And this is going to be 5955. Check something here. 39.4 has been squared. And therefore, when a number has been raised to a given power, we just multiply the logarithm by that power. So the power is 2, which means instead of squaring now for the logarithm side, we just multiply by 2. If it was power 3, we would have multiplied by 3. Remember, when it is a root, we divide. So when it is a power, just multiply. Let me give you the multiplied. This is going to be 2 by 5, 10, to give me 10 again. So we write 1, carry 1. This is a 18 plus 1, 19. We carry 1. 10 plus 1, carrying 1 now. 2 by 1, then plus 1. This is becoming 3. 3.19 squaring, or after multiplying the log by 2. Because the numbers in the numerator with those in the denominator have been divided, it means we shall subtract the logarithms. The final logarithm from the numerator should be subtracted with the final logarithm from the denominator. So we would need to take this logarithm and this one, and we just subtract. A simple subtraction. A simple subtraction now. Let's see what you get. 5 minus 0, 5. 9 minus 1, we get 8. 3 minus 9, that should be 13. Minus 9, we get 4. Then we'll be having 6 now because we've carried 1. 6 minus 1, we get 5. Point. 1 minus 3, that will be bar 2. 1 minus 3, it becomes bar 2. Now, remember there is a root 3. Remember, we are performing a root 3 now of everything, an overall cube root. That means because of the cube root, we are by 3. But when you look at this now, you discover that when we start dividing by 3, the final log should be divided by 3, or by a third. When you look at the characteristic part, that is the whole number part of the logarithm, is not directly divisible by 3. So what do? We make a multiple of 3 by saying it's just about 2. How can we make it a multiple of 3? We can make it a multiple of 3 by subtracting 1, whereby it shall become bar 3 after subtracting 1. This part, that is the decimal part of the logarithm, which is 0.5485. We add the 1 which we have subtracted from the characteristic, and that makes it, remember this is being divided by 2, then we shall add now, the other side becomes 1.5485. We also divide by 3. So when we divide the characteristic part by 3, it becomes bar 1. Then now we will be adding the other part, which is a 1.5485. We divide also by 3. And this part becomes 0.5162. That is what I'm getting after dividing now the characteristic part by 3 alone and the Mandisa part by 3 alone. So now with this final logarithm, I'm supposed to get the anti-logarithm, whereby the first part I'll deal with the characteristic and say the number whose logarithm is this should be having times 10 power 1, which is negative. So times 10 power negative 1. And now I need to get the anti-logarithm of 0. So shift logarithm of this value, and it shall be 3.2822. Remember, we are working out to an accuracy of 4 decimal places. So this is going to 0.3282. This is the accuracy of 4 decimal places, and it is the answer that we wanted. So our final answer is 0. 3282. So we are continuing to learn. Remember to invite a friend. Remember to share this broadcast. Remember to be a subscribed student to this channel. It shall be well with you. From among the greatest, people are really proud of their schools. This is Menengai High. Thank you for your kindness in helping us. Langa Langa Sek from Nakuru, from Mark G. Wonderful. Thank you so much. Ramba Boys, that is from Siaya. Thank you so much, Siaya. I am from Alliance I. How teacher present your videos in class? You are the secret of we excelling in math. Oh, thank you so much. Thank you, thank you, thank you. Send it. Timothy, we love you. Shifting grades. Wow, thank you. Thank you so much. Sironga girls, these ones are always around. Wajir. Thank you, thank you. Baringo School, Emmanuel Kiprotich. Thank you. Yeah, let's continue learning. Let's continue learning. Mangereza Academy in Naivasha. From Mang. This is great. Alliance High School. Thank you. Maranda, thank you. Mark B. These ones are ever present and active. Thank you, Machako School. Kitondo School. Thank you so much, Mr. Peter from Kitondo, for always inviting your boys to these programs. Number 6, let's continue. Given that the sine of 2a plus 20 degrees divided by the cosine of half a minus 60 equals to the tangent of 45 degrees. Find the value of a. This is one of the technical questions which can appear in an exam, but I want us to make it simple. I want us to see it very simple and doable. It's a very fair question to everybody. It's good for you students to know that there is the rule which govern what we call complementary angles. We usually say for two complementary angles, remember to be following kindly. The mathematics is more important, but drop a message of appreciation. Say hi to your teacher. Identify yourself with your school. Yeah, so we usually say that for two complementary angles, cosine of one angle is usually equal to the sine of the other. This is for the case where the value of alpha and beta are complementary. In simpler terms, they add up to 90 degrees. This setting can be twisted. It can be twisted severally. In one way, you can be told that the sine of alpha minus the cosine of beta equals to 0. That still means the same concept. You can also be told that a sine of alpha divided by the cosine of alpha is equals to 1. That means if a certain value divided by another one should give us 1, then the two values are equal. And that takes us again to the initial translation of the same. That is the third way of setting. Now, this third format of setting the same concept has been taken now to a higher level, whereby students are supposed to know that the tangent of 45 equals to 1. So when we are saying sine alpha divided by the cosine of beta equals to the tan of 45 degrees, then people should know that tan 45 is usually equal to 1. If tan 45 equals to 1, then it means we are still in the above setting. Handle it, knowing that the value of tan 45 is usually 1. Tan 45 is 1, then it means now we can now go to the question now, specifically to the 2a plus 20. These are degrees divided by the cosine of half a minus 60 degrees is equivalent to, instead of tan 45, we just write 1. Instead of tan 45, we write 1. So that means even by a simple cross multiplication, we'll get back to the initial translation. And so we can say at this level, when we take 2a plus 20 and we half a minus 60, we are supposed to get 90 degrees. And so on grouping like terms together, we will need to say 2a and half a give. This is equal to, we take 90, we add 60, but subtract 20. This is going to give us 130. And this means the value of a is going to be, we divide by 2.5. This is going to give us exactly 52. So the value of a is 52. The value of a is 52. That is the secret which students are supposed to know. The tan of 45 equals to 1. And the concept on complementary angles can be given several settings. Let students beware of all of them. St. Bakitas, that is a Bunyore. From Kitengela Boys, thank you. National, that is Busia, thank you. Tumaini, teacher wa math, Mr. Musioka, thank you so much. Greetings to math teachers. Agandegas, thank you. Nangili is in the house, thank you. Thank you, thank you. Let's go. Number 7. The position vector of P and QR. OP, negative 5i plus 4.5j, and OQ equals to 3i minus 1.5j. Wait, the magnitude of vector PQ. It's very good for students to know that there are some recommended abbreviations and symbols in mathematics which will be used in standard exams. For example, a student is, when a certain vector has been put slashes, it simply translates to the magnitude of that vector, the size of the vector, the length of the vector, the mass of the vector. So those names can be used together with this symbol in vectors. The first thing, the first assignment here is to evaluate the vector itself, vector PQ. We get the vector PQ itself, the Q minus P. I'm making them now column vectors, and we subtract P, negative 5. This is going to give us, when we take 3 minus negative 5, it becomes 3 plus, and this will take us to 8. When we have negative 1.5 minus 4.5, that will take us to negative 6.0. This is now the column vector PQ. For us to get what we are calling the magnitude now, we need to square the x component. So we'll be having now the magnitude, the PQ being given us 8 squared plus negative 6 point also squared. Then now we obtain the square root. This is automatic 0.0 square units. 10.0 square units. Number 8. Today we are going faster. People want to open schools. When you go to school, kindly say hi to your math teacher. Greetings from Shifting in School. We are here for you. The figure below shows a circle, center O, radius √2 centimeters. Given that the length of the chord AB equals to 6 centimeters, calculate the area of the shaded region, leaving your answer in terms of pi. When you're told leaving your answer in terms of pi, it means that the value of pi should not be let to be anything. You're not supposed, in any working, you're not supposed to let pi be 22/7, 3.142. You are just going to substitute pi as pi and not as a value. So let's get used to such settings. Let us get used to such settings. Remember to subscribe kindly. Remember to share so that you may invite a friend. You people are great. Hi, somebody said he's from MacB, and this is great. This is great. Thank you, Machakos boys. Moi High School, Gesusu. Greetings to Mr. Bikundo. Thank you so much. Khadija Sek in Mombasa. Thank you so much. I can see you are appreciating our work. Invite students from the coastal region. Gia Boys is in the house. Wonderful. Garissa County High. Thank you. Number 8. Let's check into this question now. We can see a circle AB. Then the radius is also given as we are told to find the area of the shaded region. The shaded region is simply what we call a minor segment of a circle. This is a minor segment. The area of a minor segment is usually given by area of a sector, and we subtract the triangle in it. So we're going to work out area of the sector, then we subtract the area of the triangle in that sector. Let me start by getting the anchor at the center of the circle, following the sector. I've first of all divided the triangle to 2 so that I have 3, then 3√2. Then I'm interested in the value of this angle. I have interest in that angle. The length, which is 3, is opposite to this angle. Then 3√2, which is the radius, is also the hypotenuse for such a triangle. And so we will use the sine of an angle. Sine theta is given by the opposite length out of 3√2. 3√2. So with 3√2 now, we can get the value of theta by simply obtaining the sine inverse. Sine inverse of 3 divided by 3√2. You can see 3 is even simplifying. So we are taking the sine inverse of 1/√2. So you use your calculator to say sine, shift sine, 3 divided by 3√2. This is giving us exactly 45 degrees. 45 degrees. So I'm getting 45 degrees at that point. Yeah, 45 degrees. Now with this angle, the bigger angle now at the center is going to be 90. So the bigger angle here is 90. It is 90 now that will be used. We'll say that area of a sector is usually given by theta over 360 pi r squared. So theta is 90 over 360 pi r squared. The value of r is 3 root 2. Now this is what we are going to square. Theta over 360 pi r squared. Remember, according to the instructions, the value of pi is supposed to be left just as it is. This area of the sector now, we shall be subtracting area of the triangle, whereby we need, okay, for the triangle, there can be several approaches. For the triangle, there can be several approaches. Remember, the vertical height is not even given for the triangle. And so we can use half AB sine theta. When you use half AB sine theta, then I can even use, let me show you. I can even use the angle of 90. Yeah, the angle of 90, then the radius on two sides, the radius there. So that I say I need minus half times 3 root 2, the sine of the angle between them, which is the sine of 90 degrees. At this point now, 90 by 360 becomes a quarter. Then something else we are that when we take 3 squared, that becomes 9, and root 2 squared becomes 4. Therefore, we'll be having pi 9 multiplied by root 2. When you square, it becomes the 2 itself. And now there is a 4 here, minus. On the other side now, it's like we have a 3 root 2 squared, which makes it a 9 by 2 again, because 3 by 3 becomes 3 by 3 becomes 9, and root 2 by root 2 becomes 2. So it will be half times 9 times 2, the sine of 90. The value of sine 90 is usually 1. So now we can finish up by saying we have by 2 1 by 2 2, which can be 4.5 pi minus by 2 1 by 2 1. So 9 times sine 90, that will be 9 times 1, which leaves it as 9. And now these are square centimeters. So that is the area of the shaded region. Shaded region. Today we are going to do mathematics. Emmanuel from Ngoto Boys, I recognize you. Thank you so much, Emmanuel from Ngoto Boys. Thank you for always following up. Friends, Mwalimu rush very quickly, save time. Thank you so much. I'm going to rush. Archbishop Eliud School, thank you. Greetings to Okwero Dennis, Butula Boys, thank you. Greetings to Madame Lauretia St. Bakitas Bunyore. Thank you, thank you, thank you. Yeah, let's continue learning. I've said I might not be able to read every message, but I'm going to do my best from this side. Mr. Vincent and greetings from your students. Momboni School, thank you. Our boys, our friends and neighbors from Momboni, we recognize you. Say hi to your principal, Peter Kilonso, Mr. Peter Kilonso. Really enjoyed so much. Okay, number 9, expand and simplify. Expand and simplify. This question, a student might think it's very difficult. And actually, remember, it has been awarded 2 marks. That should tell you a lot. That should even tell you a lot about the question. So it is a very deep question, easy to understand. It's just a difference of 2 squares, which is going to be expanded. Then we simplify and see. Upper L, thank you so much. Upper L are enjoying this lesson. This is great. Let us purpose to attend with our friends next time. Simplify. Remember also to subscribe. There is what we call a difference of 2 squares. When you are in Form 2, the topic of quadratic expressions, you learned something called a difference of 2 squares, and you said that when you have x squared minus y squared, this one be factorized. So you expand it by taking x minus y, x plus y, x minus y, x plus y. We're going to start from such a trigonometric, a quadratic identity. That is where we're going to start from. Anthony from KCSE Boys. Thank you so much, KCSE Boys. Mr. Mangaki, Mr. Mark, biochemistry teachers. Those are my friends, and I'm sure they must keep you connected. From Machakos School, keep up. Thank you. Thank you, Machakos School. Thank you, Machakos School students. Those have been great supporters to these programs. Let's apply now this identity. Remember, 3p minus 2q has been squared. Then there is minus 3p plus 2q has also been squared, which means to factorize this, we need the square root of the first term. The square root of the first term is 3p minus 2q, then plus square root of the second term, 3p plus 2q, and I have the same, but now subtracted. The same square roots. Square root of the first term will be 3p minus 2q, then minus square root of the second part, 3p plus 2q. We are now done. It's about grouping like terms together and winding up. In the first case, we will have 3p plus 3p, giving us 6p. Q, that one becomes extinct. In the next bracket, we're going to have 3p minus 3p, that one becomes a 0, plus 2q, that also becomes a 0. And so we are bracket. This one amounts totally to a 0. So the answer is a 0 in this case. The answer is a 0 in this case. Let's look at number 10. A simple question, a diagram question, easy to understand. On the figure below, which is not drawn to scale, so there is no angle that you're supposed to measure directly, neither a length. LM is parallel to PQ, just as you can see. LM is parallel to PQ, as you can see. Then there is angle MLR, 30. As you can see, this is 30 degrees. And there is also angle RPQ, 70 degrees, as you can see. Yeah. Find the value of x, again for 2 marks. Again for 2 marks. Again for 2 marks. Remember to subscribe. Remember to subscribe. Remember to invite a friend. Our Lady of Mercy, Mutuguru Gatundu, Kiambu, Charity, Choros High School. Yeah, the answer is 0. Mr. Mokaya, the Kitondo School. Thank you so much. I sent greetings to Mr. Mokaya, Mr. Peter, also from the same school, that is a Kitondo School. Greetings to Mr. Kisiani Secondary. Thank you. Koril, Indie School, Lamu. Anthony from Kisasibo is Upper Hill, Machako School. Loresho School. Thank you. Somebody from Mombasa there is enjoying our lesson. Let's continue learning. Okay, let's now look at this question. We've been told that there are 2 parallel lines here, and we must apply the concepts on parallel lines. Once they are applied, then, okay, I know there can be several alternatives to addressing this question. Let me start by extending line PR. When I extend PR, this is point T, for example, then it will mean angle 70 degrees and the angle at T here are alternate and hence equal. So 70 degrees will also be obtained from such a point. If I extend this one again, the line here, if I extend the line there, I'll also be having the angle 30 being alternate to the angle. They are called alternate angles because of the parallel lines and the transversal. Therefore, I will talk about 30 degrees. 30 degrees and 70 degrees, we shall have becoming 100. So this will be 80. And also this one will be 80. It can be 80 for 2 reasons. These are what we call vertically opposite angles, and they are supposed to be equal. And we can also see that they are equal because of the triangles. Triangle A is having already 30 and 70. So they're 80. For triangle PQR, there is a 70 and 30. So automatically, the remaining angle is also 80. They are again showing that they are vertically opposite angles, which are supposed to be equal. Now, the other two, the angle at and also the angle at Q. But we can also say, following the straight line now, PT, for example, and we have angle 80, this is supposed to be 100. And the opposite angle, vertically opposite, is also supposed to be 100 because of the 80 there. Therefore, we have filled now all the angles, but the angle marked X, it's going to be 80 plus 100 plus 80. This is supposed to be exactly 260. 260 degrees. Okay, there can be an alternative to that or alternatives, but that is one of the approaches which a student can follow. Let me show you another alternative which a student can follow. Yeah, if we drop a line L to P, from L to P, now that we got 70 here, this one, and remember being parallel, that one should be a 90. And so this is going to be 20 degrees. This one being 30, the other angle degrees. So we are having a 60 and 20 degrees, giving us 80. So the remaining angle at this point is going to be automatically 100 degrees. Now that that angle is 100 degrees, we can also ask ourselves a simple question. If R is a point, we know that angles at a point must add up to 360, and we are having 100 on the side of R, which means the other angle now, Q, is going to be 360 minus 100, again giving us the same value. So we can use such an alternative. Boys, wish you could send a picture of the exam for future reference. Yeah, request in your group inbox. My number is already on the wall, so you can use to request for the paper. I'm going to share it through WhatsApp. Thank you so much from Machako School. Greetings from Mishak. This is from South Boys High School. Greetings to Mr. Yuma, Mr. Yuma Rogers. Wilson from Baringo Boys. Thank you. Thank you. Thank you. Let's continue learning. Let's continue doing it. Mathematics for life. NAPA 11, which is on geometry and constructions. Geometry and constructions. On this one, I'm going to issue some guidance using a ruler and a pair of compasses only. Construct a parallelogram ABCD in which AB equals to 7.2, BC 4.5, and call DAB equivalent to 105. Drop a perpendicular from D to meet BA produced at M. Measure the length of DM. So this is going to be a simple construction whereby we can start with the 7.2 AB. 7.2 AB. Remember, I'm just issuing guidance on this. I don't have a 7.2. I'm not having some equipment for construction on the screen. So I just have to guide 7.2, or rather I'm giving a sketch. 7.2. Then the angle at A is 105. For us to get an angle which is equivalent to 105, we are supposed to know that 105. We just need 90 degrees. Then after getting 90 degrees, on the other side, we construct 60 to remain with 30, whereby when 30 is bisected, now we will get 15. So I need to raise a perpendicular at this point, just a perpendicular at point A. Then again, standing on A, I need to construct 60 on this side, such that with 60 at that point, 30 remains at this point now. Between the 60 and 90, there is a 30. Now I bisect this 30, which means 30 will give me 15, 15. When I add 90 and 15, this is now 15. This is 90. So the combination of 15 and 90 is going to give us a 105 degrees. So at that point now, we can measure a length of from B to C. Remember, it's a parallelogram, which has two pairs of parallel lengths and two pairs of other parallel lines, which are also equal. So BC being 4.5, then it means AD is also 4.5. So I'll measure 4 centimeters. And that means we can have our length of 7.2, and we stand at this point. We just make an arc using a length of 7.2, and we stand at D. Using a length of 7.2, we stand at 4.5, and we stand at B. We make an arc again. Intersecting, they will give us our point. They will give us our point C, and so we will be able now to produce our parallelogram. Remember, I'm just issuing a sketch. I'm giving you a sketch diagram. I said When we stand at D, having a length of 7.2, then we stand at B having a length of 4.5, and we make arcs, they will intersect at point C. At point C, now we can connect it to the other 3 points. At this point, now we can proceed. Drop a perpendicular from D to BA, produced at M. So now we are going to prolong BA such that a perpendicular can be dropped from this point. We just make arcs there, and we use those arcs to get other arcs, so that now we can get us very perpendicular at M. Then we just measure. You just measure. So that is what you'll be having. Remember to measure and get the exact value. Yeah, so those who are going to get the paper, to measure and get the exact value. We are continuing. Marsan, that is Kericho High School. Thank you so much. Greetings to Mwalimu Christopher, Loresho School, Nairobi. Mike from Makueni Boys. Thank you so much, Makueni Boys. You can see Moigals Kajiado. Thank you so much. Githurai Secondary School. Thank you. I can see Felix from Dome High. Thank you. Hi, it's Laventa here. Emmanuel School's fully tuned. Keep it up, teacher. Thank you so much, Emmanuel Springs. Remember to send greetings to principal, who is my friend. That is Mr. Savali Dixon Mangela. We continue. Sunshine, thank you so much. Mr. Kisini Momboni School, thank you. Thank you. Okay, let's look at number. Given that A equals to -2, B equals to 5, and C equals to -1, evaluate. For A power 3 plus 5, B minus C divided by a third, C squared minus A squared. Yeah, this is the normal substitution. The normal substitution. A Form 1 student can even attempt this question. Even a Form 1 can attempt this question. Andrew from Machako School. Good work, my teacher. Thank you so much, Andrew, Machako School. Thank you for finding time to follow. Thank you so much, Andrew. Yeah, Machakos boys at Machako School, and we love them. Thank you so much for being around. This is an obvious or a usual substitution question, a concept learned in the Form 1 mathematics. Let us look at what we shall get. So we write for A power 3, that will be -2 raised to power 3. Then we add 5. The value of B is also 5. Then we subtract. Careful, more so when the values involve a negative. Divided by a third. The value of C squared, -1 raised to power 2 minus A also squared, -2 also squared. We can work out, because there are 3 marks, we are not supposed to rush. Let's just get our marks slowly. -2 power 3 is going to be, -2 power 3 will be -8. This must be multiplied by 4 to give us -32. Then we add 25. Then minus -1 becomes a +1. That is on the numerator. On the denominator, we'll be having a third A third into, this is a -1 squared, making it 1. Then this is a -2 squared. It first of all becomes 4, which is positive. So we'll be minusing 4. It should be -4, like that. Because it's minus. When you when -2 is squared. We continue answering the question. Negative plus 25 plus 1, that gives us a -6. Divided by, we'll be having a third into -3. A third into -3. That will make it a -1. So we shall have -6 over -1. -6 over -1, giving us 6. So the final answer is 6 from that question. It becomes positive because a negative divided by a negative divided by a negative will automatically become positive. We can look at number 13. Thank you. I can see you guys are still Gedi High School. Thank you. Joro Girls, thank you. Those ones have been following. Thank you. Upper here, the lesson. Thank you so much. Love from Sunshine. Thank you. We are almost winding up, so don't give up. Let's continue doing it. Number 13. In our relay heat, this should be heat. A relay heat. Omanyala, Kiviasi, Imeta, and Mukamba took 9.68 seconds, 9.72 seconds, 9.88 seconds, and 9.77 seconds, respectively. If an average of 0.65 is spent on each button exchange, the time they completed the race, if the race started at 11:59.32 a.m. 32 a.m. So let's check this question. We are simply going to add total time taken. I request again, we just add time slowly. Let's take time to add. We are adding seconds, and when a second is having some fractions or decimals, those decimals are called centiseconds. They are needed 100 of them to give us a complete second. So we call them centiseconds. For example, when we take 9.68, the time taken by the first athlete, and we add 9.72, this is going to take us to 68 plus 72. This is 140. We can have 40 centiseconds remaining here, and we carry a complete second to give us a 9 plus 9, 18, then plus 1, 19. Then on 19.40, we add 9.88. 9.88. So we'll be talking of 40 plus 88, 128, which means we shall write 28 at this point, and we carry 1 full second, because the centiseconds have already added up to 128. There is a complete second there, so we have the remainder of 28 centiseconds, and we carry 1 second. 19 plus 1 gives us 20, and so we shall have 29. 29.28. Then we are also adding 9.77. So 9.7, when we add here, it means we are taking 27. That gives us 105. And this means we can remain with 0.5, or simply 5, what we call centiseconds, and we carry a complete second. So 39 seconds. That is 39 seconds so far. Let's get back to the question. Because it's a relay which was being spent during the exchange of the baton. And during the exchange of the baton, we have 65 centiseconds each. And they are 4, remember. But even if they are 4, you should know that when the first person picks, this is a Omanyala. When the first person picks, there will be the first exchanging here. Then this second person who has been given is going to run, and third person, and that is the second. Then this person is going to pass over to the fourth person, and this will be the third exchange happening. So after the third exchange happening, now this other person will just go to the finishing line. He's not going to hand it over again. Therefore, the 0.65 seconds going to be consumed in 3 scenarios. Even if the gentlemen are 4 in the race, the baton will be exchanged 3 times. From the first person to the second, from the second person to the third, from the third person to the fourth, but now the fourth person will just go to the finishing point. So 65 centiseconds should be multiplied by 65 centiseconds by 3. That's 195 centiseconds, which means there is 1 second 95 1 second and 95 centiseconds. So now we can add to 39.05, we add 1.95. This is going to give us 100 centiseconds, whereby we will carry it as a whole second, yeah, and we remain with 00. Then now this will be 41. So the total time taken is 41 seconds. 41 seconds. 41 seconds is the total time taken. 41 seconds. When you lie to yourself and start rushing to add with a calculator, you shall not get anything. A calculator will just complicate this simple question. Calculator will just complicate it. All right, now we can see the starting time was 11:59. 3:2. We go to the second side. These are hours, these are minutes, these are seconds. So we are just adding our 41 seconds here. And remember that we require only 60 seconds to get a minute. We require only, when the minute is added here, where there are 59 minutes, hour, and we're going to have 12. So this is 12:00:13. It is now PM. That is when the race is going to end. That is when the race was complete. You can be sure a student who rushes just to use the calculator will not be able to maneuver through such a question to the end. Thank you so much. Somebody says the screen is not visible. I'm going to confirm that. I'm going to confirm that. But let's keep following. Number 14. Remember, tomorrow we'll be doing section 2. Not opening schools tomorrow for a very powerful session of mathematics. Let's look at this question now. Form inequalities that satisfy the given region. Form the inequalities which satisfy the region below. When we look at this question, you discover that from Kabaregas. Mr. Kisa, the math teacher, received greetings from Susan. Yeah, these are lines. We have L1, L2. They are bounding a certain region. We should form inequalities. Let me start with L2, which is very simple. It's passing through 2.5. So that is a line y equals to 2.5. But we can see the region is below that, smaller values than 2.5. So we can say it's y less than 2. This is L2. Y less than 2.5. I've not written or equal to simply because the line is dotted. If it was a complete line, then I would have written or equal to. We can do one now. This is a sloping line, and it means we are supposed to first of all get the gradient. For us to get the gradient, we obtain two coordinates along which the line passes. A coordinate like 1, 3. Another coordinate like -1, -3. Those are two coordinates along the line, and we can use them to calculate, first of all, the gradient, then the equation for that line. So 3 minus -3 divided by 1 minus -1. This is going to be 6/2, and this is going to be exactly 3. With a gradient of 3, now we can see that by changing y minus 3. I'm picking a coordinate xy, and one of the coordinates that we have picked, then x minus 1 across is going to give us y minus 3 equals to 3x minus 3. So to remain with y at this point, we can have 3x minus 3 plus 3 becomes 0. So it's y equals to 3x. If that's the line, now we can determine the that we are going to use. We determine that by picking one of the coordinates in the required regions. Let's say a coordinate like -2, 1. A coordinate like -1 means where there is x, we put -2, where there we put 1. So the coordinate is -2, 1. -2, 1. So 1, then 3, -2. This is going to be 1 and -6. Now, when we examine the relationship between whether strike equal your school administration kindly. Yeah. Okay, let's inspect between 1 and 6. How are than -6? And so we shall say is greater than 3x. Finally, we can look at L. Need just 2 points lying on the line. 2 points like 2 points. Let me pick this one. It's good for you to pick a fixed coordinates or definite coordinates, which are not having a lot of fractions or decimal places, like negative 6, 3. Then there is another coordinate, negative 4, 0. Negative 4, 0. So we start by taking the gradient 3 minus 0 divided by negative 6 minus negative 4. This shall be 3 out of negative 6 plus 4, giving us a negative 2. So the gradient is negative 3 out of 2. This gradient can be expressed using yx or xy and another coordinate, one of the provided coordinates. So y minus negative 4 makes it y plus 4. Then we shall divide by x minus 0. 2y plus 8 after cross multiplication equals to negative 3x, because the other one is a 0. So it will just, yeah, section B will be done tomorrow. So let's just wind up with section 1. We are at number 14 over 16. So we are finishing. Ladies and gentlemen, relax. 2y equals to negative 3x minus 8. Negative 3x minus 8. So for this one, we can divide through by 2, which is not a must. We can just answer the question the way it is. Let's handle it at that point. Let's just deal with it at that point. We pick the coordinate negative 2, 1. So negative 2, 1 means where there is y, we have 1, but where there is x, negative 2. So negative 3, negative 2 minus 8. This is going to be 2, but this one will be negative 6 minus 8. Negative 3 by negative 2 becomes 6. 6 minus 8 becomes negative 2. So the relationship here is greater than again. If it's greater than, we can also make another observation and see that L3 is a complete line. Therefore, apart from saying that 2y is greater than negative 3x minus 8, then we shall include or equal to. This is L3 or equal to. So that's how we get the coordinates. That's how we get the inequalities. We are finishing up. We can look at number 15, yeah, which is a very simple question. Good for your application, good for your knowledge, good for your knowledge. Let's yeah, people are asking for the paper, and that is good. I'm going to share the paper after this lesson, so stay patient. I'm going to help you out. Okay, number 15. Points x negative 1, 4 and y negative 2, negative 1 are mapped onto x prime 2, 11, y prime an enlargement. Find the scale factor and the of enlargement. Some of the questions which have a multiple approaches can be this nature. Let me show you a simple approach to this question. I know nowadays it has been highly evaluated, and we can take vector xy as our image, as our object, sorry. Then it's being mapped now onto x prime, y prime. We take that one as our image. So we'll be saying xy as the object. Let's take the vector there. or the magnitude, or the displacement xy. Displacement xy is going to be -2, -2 again, sorry, minus negative. Now the displacement from x to y is going to be -2 plus 4, which makes it a 2. The -2 minus 1, making it a -3. This is the displacement from x to y. What about the displacement from now x prime to y prime after the enlargement? After the enlargement, what's going to be the displacement? So we need 8 to minus 211 after they have been enlarged. What is the displacement between the 2 points? I'm seeing 6 and -9. Now we can check, because what we call an enlargement scale factor is something like just a multiplying factor, such that there is a uniform factor which multiplies one of the vectors into the other. And so we can say the scale factor, which is unknown, we can call it t. The scale factor t, when it multiplies to -3, it should give us the image. So following the x components, the scale factor t is going to be 2t equals to 6. I'm getting again -3t equals to -9, and it confirms that t equals to +3. So we are having a positive scale factor, a positive scale factor of 3. A positive scale factor of 3. We are winding up. A positive scale factor of 3. Now, with a positive scale factor, remember now we have, let me check what guys are saying here. I can see everything is flowing on well. Wow, thank you. People are saying that they have learned a lot. Thank you so much. Chesamisi, that is my school in Bugoma County. Thank you so much. Okay, let's wind up with now the center. We are supposed to know something again, that when we take the distance from a point to the center and we divide the distance again to where the image is, we get the scale factor. Let me show you what I mean. When I take the distance, assuming that the center is AB, let the center be unknown. Assuming that we have a center AB, then the distance from where the image of x is to the center, it's going to be, we take 2 minus a and 11 minus b. This distance is the same as 3 multiplied by the distance from x to the center. So from x to the center, it shall be a minus -4 and b minus 1. So from the center to where x prime is, we express it this way. Again, from where x is to where the center is, we express it this way. But now we are saying this distance is 3 times the other one. If it is so, then we can now use the x components to get y, to get a. So 2 minus a equals to 3a plus 12. I'm adding 12 because negative -4 becomes +4. So 12 like that. we can have this one becoming a 4a. Then on the other side, we shall have it, 4a. 2 minus 12 gives us 10. So we shall have now 2 minus 12, giving us negative 10. So when I divide this one by 4, I'm getting negative 2.5. Then I finish up now. I finish up by getting the value of b. So I love to say that 11 minus b is equivalent to 3b minus 3, because 3 is multiplying everything there. So we will have this one as 4b, and this one is 14. So the value of b shall be, when I take 14 minus 4 or divide by 4, I'm getting 3.5. Therefore, the center shall be negative 2.5, 3.5, 3.5. Mother Aura says that they have learned a lot. Finally, number 16 in the section 1. 16 in section 1. The figure below shows a forest sanctuary drawn on a square grid, side 1 centimeter. Part A calculates the area of the forest in square centimeters. So the area of the forest in square centimeters, I'm hoping that the screen is going to stabilize. Yeah. Just the screen is getting better. But remember that for us, yeah, thank you. For us now to get the area of such a figure, which is irregular, we first of all count. We just count. Yeah, I'm working on the screen. I'm working on the screen to ensure that it becomes clear. I think it's now clear and everybody can see. I hope now everybody can see. I think it's now clear and everybody can see. So we're going to take the complete squares. Section 2 will be done tomorrow. Remember to be around. So the complete squares, we're going to have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Therefore, I'm having 27 complete squares. Yeah, 27 complete squares. Then now I count the squares which have been occupied partially. So I can have these ones counted from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So I'm having 33, which have been occupied partially. So I'll add half by 33. This shall give us 27 plus 16.5. 16.5. Yeah. This gives us 43.5. So 43.5 square units. 43.5 square units. 43.5 square units. This section B will be done the same time. So tomorrow the same time. Tomorrow the same time. We have done the area as 3.5. Given that the forest sanctuary covers an area of 6,960,000 as, determine the linear scale used. Determine the linear scale used. It's good for you to know that in such a scenario, we first of all need to, for us to get scale, we need to get the areas in the same units. We should know that 1R is usually equal to 1,000,000 square centimeters. And so at that point now we should say that the area which has been provided here as 960,000 will be the same as we multiply 960,000. Now we multiply by 1,000,000. So we expect now the zeros to in as square centimeters. So we have converted the area to square centimeters. But now remember that the area of the land divided by the area on the map will give us the scale used. So the linear scale is going to be the area that is the area on the ground divided by area in the map. These are square centimeters. Area in the map is 43.5. So when we carry out such a division, we are dividing 6,960, 1, 2, 3, 1, 2, 3, 1, 2, 3, divided by 43.5. This is giving us exactly 1.6 times 10 power 11 times 10 power 11. So now we can just take the square root. Remember, actually, because we have divided two areas, whatever we are getting here is area scale first. So the linear scale now shall be the square root of this area scale. Yeah, when you divide two areas, you get area scale factor. And for you to get linear scale factor or linear scale, you just obtain square root. And this is going to be 400,000. So the linear scale was 400,000, which can also be written as 400,000 is to 1. That is 4 centimeters. Or 1 centimeter is to 400,000. 1 centimeter on the paper represents 400 centimeters on the ground. So that is how the last part was being done. We really appreciate for the good work you're doing. Thank you so much for recognizing our work. Thank you so much for recognizing the work that we are doing. So remember to subscribe to the lesson. Remember to share the link. Remember to invite your friends in our next broadcast, which is going to be tomorrow. Thank you so much. Good night.